Logs, logs, logs. Super, super confusing for students, but a very important topic and something that if you can nail in all the different ways, whether that be looking at log laws, differentiating, integrating, solving equations, this will be what separates you from a band 6 student and a band 4 student, literally. All right, so in this lesson, I'm going to go through all the different ways that you can differentiate a log function. This is going to be a very extensive video. And by the end of the video, you would be a true master in differentiating log functions. And there's also going to be formulas in here that you don't see in your textbook. All right, now the rules for differentiation can be broken down into these 4 formulas. Like I said, one of this is not in the textbook, shocker, but you still can be assessed on it. Now, base, we're going to be breaking it down into where the base is e and the base is not e. Very similar to exponentials, okay? Logs and exponentials are like cousins, they're like brothers. So usually they are like matching in some way, but not exactly the same. All right, so first of all, when the base is e, if you have ln x, the derivative is 1 over x, like we saw. For example, if you have 2 ln x, the constant 2 just chills, he's a little spectator. And then if you just differentiate ln x, you get 1 on x. So then when you times those 2 constants together, you get 2 on x. Perfect. Now, the one that is more commonly explored is when you have ln of f of x. So what that might look like is if you have ln of 2x plus 1, or if you have ln of x squared, where the thing that you're taking the ln of is something more complex than x. So what this is going to be equal to is, well, first of all, you're going to notice hopefully that the ln just goes away. No more log once you differentiate. And then what you do is you take the derivative of that f of x, that goes to the top, and then the original goes on the bottom. So fx over f dash over fx. So for example, if I had ln of 3x plus 4, ignore the ln, we're only looking at what's in this bracket. Take the derivative of that bracket, that's 3, that goes at the top, and then you divide it by itself. Beautiful. So simple. Okay, now where it starts getting a little bit confusing is when the base is not e. So if you have log to the base a of x, you need to be so good and comfortable with differentiating that as soon as you notice that the question has a base that's not e, your mind should be coming to these 2 formulas, not the other ones, because they're not going to work the same. So here it says if you have log base a of x, then this is going to be equal to 1 over ln a times x. So the way that I think about it is you're kind of still ending up with 1 on x, but the only extra bit here is that you're timesing the denominator by ln of the base. Okay, very similar to the exponential. So for example, if you have log base 2 of x, you're still going to get 1 over x, but you also need to times the denominator by ln of 2. Okay, and then the very last one here, if you have log base a of f of x, then it's going to be a combination of this rule that we've just learned and also this rule over here. So this is going to be when you have a base that's not e, and then you also have something a bit more complex. What you do is you take the derivative of f of x that goes at the top, you divide it by itself, okay? And then you still divide or you times the denominator by ln of a. Okay, so for example, if you have log base 3 of 2x minus 1, you're going to take the derivative of the top, that becomes 2, bring that to the bottom, and then you take ln of the base, which is ln of 3. Yay, that is all the 4 formulas summarized. So now let's test our understanding by going through all sorts of examples. I'm going to be going through a lot of examples. Feel free to pause the video, have a go yourself, and then unpause it and see if you've got the same thing as me. Okay, checkpoint. Example 1. Differentiate y is equal to x squared minus 3 ln x. So over here, you're going to notice that we are combining it with also just an x squared term. So if you differentiate that individually, you get 2x. If you differentiate ln of x, that's going to be 1 over x. And then that little negative 3 there is just spectating. So that's negative 3, come to the front, times 1 over x. And then just to clean this up, we're going to get 2x minus 3 over x. Stunning. Next, example 2, differentiate y is equal to log e of x squared minus 4. Now remember that log base e is the same thing as ln. I'm going to mix them around so that you become familiar with it. So this is going to be in the form of y is equal to ln of f of x. And according to the above rule, its derivative is you take the derivative of the top divided by itself. Okay, so that means I'm only focusing on this guy over here. So when I focus on that guy, that derivative is going to be 2x over itself is x squared minus 4. Beautiful. That's it. Next one, example 3, differentiate log base 10 of x. Okay, so notice how the base is not e, the base is something else. So we're going to be using the formula that if you have log a of x, its derivative is going to be 1 over ln a times x. So that means we're going to get y dash equals to 1 over ln of 10 times x. Okay, you can see there's not a lot of working out. The thing is you just need to commit this to your memory. That's the main thing. Just keep doing examples, practice, practice, practice. You know the go. All right, now example 4 here, you're going to notice, hopefully, base is not e, and you have this more complex thing inside your log. So this is going to be in the form of y is equal to log a of f of x. According to the above rule, this is going to be f dash over ln of a times f of x. Okay, so I like to think of it as, if I differentiate this, take the derivative as if you were to have something that's not just x, so 2 goes at the top, 2x plus 5 goes on the bottom. But since the base is not e, it's 3, we're just going to put on the denominator ln of 3. Fantastic. And the next one, example 5, differentiate y is equal to ln of x. Now this one looks a bit funny. You have the ln of an ln, or the log of a log. Okay, now this is actually in this form. It's in the form of ln of f of x. That means that f of x is actually acting as this ln x. So if I were to differentiate it, what we're going to do is we're going to take the derivative of that. The derivative of ln x is 1 over x, and then you divide it by itself. And that's your answer. Now, if you know me, if you watch my videos enough, or if you're my student, you will notice that I very much dislike it when there's fractions in fractions. Never ever leave it in that form. Okay, you might get a really cruel teacher who says, no, this is not simplified enough for me, and then they mark it wrong, even though you know your stuff. So to avoid that, always rewrite it in the correct form. Now, the way that I deal with this intuitively, okay, instead of, having to follow these tips that don't really make sense, I think of it as this is 1 over x divided by the bottom. So if I rewrite this out, y dash equals to 1 on x divided by ln x. And whenever you have a divide, it's the same thing as timesing it by the reciprocal. Okay, so times 1 over ln x. And then now if I just combine it, we get 1 over x ln of x. Beautiful. Okay, now for the next set of questions, you actually need to know your log laws before you're able to tackle them. So over here, I have written down all the different log laws that you need to know. So this video is just for differentiating log functions. It's not really a video about the log laws. So I am going to leave this here for you if you want to write it down. I will go into more depth into these log laws and practicing them in my log laws video. So use log laws to simplify, then differentiate the following. So if I look at this one here, you can see that we have the log of two numbers timesing each other. And I should actually write that this is log base e. That was a little bit of a mistake on my part. So if you were to hypothetically go about differentiating this, you might say, Miss, isn't this in the form of ln of f of x, where this is f of x? If we treated it like this, you're going to notice that we're going to have to use product rule because we have the product of these two fractions. Product of these two brackets, x plus 1, x minus 2. Okay, if I can avoid product rule, and if I can especially avoid quotient rule, I will do that at all costs. So what I'm going to do is I'm going to split it up using log law. So we get log e of x plus 1 minus log e of x minus 2. Plus. So now I have two separate simple logs where if I were to differentiate it, they're going to be in the form of ln of f of x. So we get the derivative of the top is 1, the denominator is x plus 1, plus the derivative of the top is 1, and the denominator is x minus 2. And that is your beautiful little answer using log laws. Now, similar thing, example 7. Differentiate y is equal to ln of 4x plus 1 over 2x minus 7. So you can see here that we have a division of 2. If I want to differentiate this, I'm going to first split it up using log, the second log law. So when you split it up, it becomes minusing these two logs. And then now these are two more simple logs that I can easily differentiate, so I don't have to use quotient rule. Whew, thank God. So now the derivative of this is 4 divided by itself minus the derivative of that is 2 divided by itself. Now, technically, if you didn't realize that in the exam and you just did this way, and then you perform quotient rule and all of that, you're not wrong. It's just going to take you probably 5 times, 6 times, 7 times as long. And each time, every single second in the exam is just super important. Okay, now the next one, example 8. Differentiate y is equal to negative a half ln of x cubed. Okay, if I were to differentiate this, you can treat this as f of x, no problemo, but since we want to use our log laws, I'm going to notice that this 3 is a power on the x, so I can actually chuck that to the front. So we end up with y is equal to negative a half times 3 is negative 3 on 2 ln of x. And then if I differentiate this, we get negative 3 over 2 times 1 over x, which if you just combine it, negative 3 over 2x. Great. And the last one for the log laws is differentiate y is equal to ln of 2 minus x. How would you approach this? Well, what I'm going to do is, and I have this instinct every time I'm dealing with different derivatives and integrals, is anytime you see a surd, so square root, change it to a fractional power. So this is going to become 2 minus x to the power of a half. Now, just so we're clear, this here is the same thing as log base e of 2 minus x to the power of a half. So this is that log law that says that if you're in this form where you have a power of n on that x, so this is our n and this is our x, you can chuck that power to the front. Okay, so if I chuck that power to the front, we're going to get half of ln 2 minus x. Okay, and now once again, I'm dealing with a more simple type of log function. So now if I differentiate it, we're going to get our constant out the front. The derivative of the inside is negative 1, and then itself is 2 minus x. So this is just going to become negative 1 over 2 times 2 minus x. Okay, and then the last set of questions to fully unlock every single way that you can be asked a log function is to use chain product quotient rule. Okay, so differentiate the following. Y is equal to brackets 2 ln x plus 3 to the power of 5. All right, so you can see it is going to be chain rule because you've got the inner function, you've got the outer function. So if I perform chain rule, bring the power down, reduce it by 1. And then the last step of chain rule is you want to times it by the derivative of the inner function. So the derivative of the inside here is going to be 2 times ln x is 2 on x, and then 3 just becomes a 0. So now the last step is just to clean this up, make it look nice. 5 times 2 over x is 10 on x times all of this guy here. Okay, and then you can just leave it in that form. Lovely. Next, example 11, differentiate y is equal to x squared log e of x. So you can see, can you notice what rule? Product rule, right? We have a product of 2. So u is going to be x squared, u dash is going to be 2x, v is going to be log e of x, and v dash is going to be 1 on x. So if we use product rule, the product rule formula is vu dash plus uv dash. And then if we plug this into product rule, we're going to get this times this. So 2x log e of x plus x squared times 1 on x. Okay, and hopefully you can see that in the second bit over here, one lot of x cancels out. So we end up with y dash equals to 2x log e of x plus huzzah. And you know what? I'm just a sucker for simplifying. So I'm going to take out an x, and then we get 2 log e of x plus. Great. And then the very last way is using quotient rule. So if I use quotient rule over here, because you've got the u here, you've got the v, let's set out our little rules. U is e to the minus 2x, u dash is minus 2e to the minus 2x, v is going to be ln x, and v dash is 1 over x. Okay, I know I did this really quickly, but if you are still struggling with how to differentiate exponentials, please watch my video over here. I'm going to put it somewhere on the screen, okay, and then it will make this more easy to understand. And now for product rule, just to recap, how do we memorize it? Don't look at the reference sheet. V is on the outside forming a V. Okay, we're going to have a minus because it's quotient rule, minus and divide similar, and u dash before v dash. Perfect. All right, so now v times u dash is going to be these two times each other. So I'm going to write minus 2e to the minus 2x ln of x. These two minus each other, minus e to the minus 2x times 1 over x, all over ln of x all squared. Beautiful. And now we just need to simplify this. Now, this looks a bit not nice. Multiple things here, lots of negatives going on. Also, this here is the biggest red flag for me, is because I don't like fractions within fractions. So if I want to get rid of the fact that there is an x in the denominator of my numerator, I need to think, what should I times it top and bottom by to get rid of it? And I'll help you like really think about this first before I do it, because I want you to like use your brain a little bit. If I had, let's say, if I wanted to get rid of the fact that there's a fraction here, what should I times both of these expressions by? Just a 2, right? Because then x on 2 times 2 gives you x, and then 4 times 2 is 8. Okay, so the hint here is that I want to times it by the denominator. So in that case, I'm going to times this by x, but you can't just times the numerator by x, you need to balance it. So I'm also going to times the bottom by x. When I times this by x, let's start from here. That's just one term. So that's going to become y dash equals to minus 2x e to the minus 2x ln of x. And when I times this second term by x, the 1 on x and the x cancel. So we're just left with minus e to the minus 2x. And that is all on ln x all squared. Fantastic. And the last thing I want to do is I just want to simplify the numerator so I can see what is common is they both have e to the minus 2x. And they also both have a negative. So let's take that out. Minus e to the minus 2x. We're going to be left with positive 2x ln x and then plus 1. And that is all over ln of x all squared. Oopsies, and I forgot to times it by x on the bottom. Yay! All right, so I hope you guys enjoyed that video. You are now ready to tackle all those hard questions in the textbook and also in your exam. Thank you so much, and I'll see you guys in the next study session. Bye.